Today, a look at Intel Optane 32 gig tiny little caching module. This is under $100. Here's my tweet about it. This will be my very first time I'm having a look while it's installed in my super server. I installed it and then hit the road for a few days, and now I'm back. I've been eager for this moment to finally look at it in my vSphere cluster and see what it can do for performance. So to point this out here, we're not talking about memory extension or any of that. This title says it all. Intel Optane can be an ultra-fast vCN cache. All right. It can also be just straight NVMe storage, which is not really a use case because it's tiny. It's 32 gig, right? But I'm going to do it anyway. So it's not really a production use case. So here's a cluster, the HTML5 client, now known as vSphere client simply. The Optane is installed in this machine. And if we have a look here and go to configure storage adapters, we'll see two different NVMe adapters. All right, let's go to NVMe. Let's go here to the vSphere web client. Go to configure. Storage adapters. And we're seeing a little more detail there, but not much. Okay, so one of the NVMe's is right there. There it is, Intel. Cool. All right, this is my very first time having a look at it. There's no file system on it. How about the other one? That's a Samsung 916 that has stuff on it. All right, let's go to storage devices. Look. Got quite the variety pack in this particular machine. And this is how the Intel Optane looks. No partitions at all. Okay, bounce back over to host client. So you're having a look with all the UIs. What does this thing look like before we bother to do anything with it? All right, so you're not going to see it from that level. Go to host. And, well, storage adapters. We'll do it, I guess. That's about as far as we can go in the host host client. Okay, controller for the adapter, and then NVMe device, Samsung there, or back arrow once. So if we do new data store, we'll see unclaimed devices. Okay, we're on the wrong server. Okay, here in the host client, what are we able to see? Under hardware, you're not going to see it there. That's just fans, RPMs, and that stuff. So under the host client, we want to go to storage. You can see all my devices there, quite a variety pack. Here's what the Intel NVMe device looks like. And if we say new data store, we can see that it'll allow us to partition it, but it's only 32 gig in size. Okay, very important to point that out. Again, it's small, but should be enough to run a VM or two and get a sense of the speed. All right, so now we've had a look at what this thing looks like from all the different client UIs. And I think it's time to get started with actually using it. So I'm going to right-click, choose storage, new data store. All right, so it looks like I have a bit of a naming scheme going already. Actually, it doesn't show on the left, so for now, I'm going to call it Okay, it helps if I select the proper drive. There it is. Scroll to the right a little bit. It's recognized as flash type. That's good. VMFS6, sure. Fill her up, yes. And finish. Likely it's not going to take very long. Okay, so there's my data stores. Now, if I right-click and rename it, I should give it a better name, like NVMe for the interface type, Optane for the module name, and then finally which server it's physically in. Since this is not shared iSCSI storage or something, it can be pretty fuzzy on what server local data stores are in. I kind of like to throw at least 4 digits of the name of the server right there in the data store. Okay, so now we know what we're looking at. Time to get a VM over there. So, do I have a template ready to go? And I did some paravirtual versus LSI. They were about the same. I'm going to go with paravirtual. So I'm going to go template. Oh, okay. This thing needs to be converted to a template. Looks like I was staging or working on this VM, and it wasn't actually marked as a template. Now you get the template icon. Now I'm ready to say new VM from this template. Win 10 960. So this time Windows 10 is going to be on a 960 for a comparison. Let's clone to that first, right inside the server. And I'll just power on the VM afterward. Why not? Okay. 39%. And I'll call this one Windows 10 Optane. Now VMs can be moved. It's not a great naming scheme. It's really just to make this video clear that I'm going to have 2 VMs that I'm going to use and only 2 VMs that I'm going to use, with very abundantly clear names so you know which is running on what. These are thinly provisioned, and actually that first clone should be done soon, so the 2 clones won't be kind of in the way of one another. And I could actually do a bit of informal stopwatch benchmarking. Let me set that up. I'm going to move my Camtasia recorder here, and that'll act as our stopwatch. So when I get to 8 minutes even, I'm going to hit next. It's going to start deploying that VM. We'll get a sense of how long does it take to copy from, I believe the 960 is where this template is on. We'll double check that. Over to this crazy fast Optane, which should have amazing write speeds. Okay, I missed that by a second. So the first operation took 43 seconds. But if that was banging away, if the template lives on the 960, well, that's not really fair, yeah. So it was reading and writing to the same drive. That's the worst abuse you can imagine. But now we're going over to the Optane, and let's see what we get. Now there might be thermal issues here too. I don't even really know if this thing's going to heat up enough to have thermal throttling. Anything like Samsung 950 EVO or 960 Pro or EVO. Which have gotten better as we move from 950 to 960 over on the Samsung side. On the Intel side, we're about to find out if I abuse the drive for a while with reads and writes simultaneously, does thermal throttling start to take effect and affect the speed of some of the VMs? Okay, so 48 seconds. All right, so the speeds there were similar, but the 960 was involved in both. Now it's time to actually have a look at Optane booting up. Okay, I'm going to launch Remote Console. And I want to do the same for the 960. Get Remote Console going so you can see both. Okay, so we have a side-by-side now. And I could probably reduce a little clutter by minimizing some UIs. And let's just see how these 2 VMs look. Now, Windows updates and other junk might happen on this first boot. This first boot doesn't mean a whole lot. So I'll just point that out. I tend to just kind of throw it away. This one on the left looks very busy, and its clock is actually lagging. It hasn't synced yet. Okay, so VMware tools, these are set to sync with the ESXi host. And for whatever reason, the machine on the left is choking a bit on this first boot. So one thing we can do, or I can do, is detach the network adapter to prevent Windows Update and other background processes from kind of mucking things up a little bit as I start to have a look at performance. Or I can just leave the machines alone and come back when they're done with catching up with Windows Update, since they haven't been powered up for a week or two or so. Now if I show you over here, there we go. They are both the identical machine, same build, same all of that. All right, in the interest of time, getting this first test going, I'm going to, since we're out of band using VMware Remote Console, right? We have access to this VM whether or not a network adapter for like remote desktop connections and stuff is available or not. So we can actually just disable the NIC from inside the VM, or I could actually detach the NIC from it within VMware IC console. Actually, that probably makes more sense. Let's just do that. Okay, the NIC is now detached on the right, and we get red X through it, and Windows Device Manager is angry at us. And in fact, even at power on, I want it to be missing. So let me go a little more drastic and say, I don't want that NIC attached even after, say, maybe power cycling. All right, so we should get into a steady state now where the VM is good to go, including after a reboot. So that I'm going to test next. And I'll go ahead and reboot both of these VMs. All right, there's another thing I'm going to do here, and that is to take care of cooling. So IPMI interface lets me go in to the administrative interface of this Supermicro system and crank up the fan speed to full speeds to minimize the chance of this first disk benchmark being affected by thermal throttling effects. Okay, so both are rebooting. The one on the left clearly lagging. Optane machine on the right already acting a little snappier. Might not mean anything. Reboot tests are not the greatest. A lot could be going on during a reboot, but at least now with the network eliminated, we're not going to have, again, some sort of Windows Update thing happening. Now in this reboot, I'm not seeing something like applying Windows Update at reboot, right? So that's a good sign that we have a clean situation here. But it is interesting how long both are taking. Not quite sure what's up with that. While I wait for that, we can have a look here and just see. Sensor readings, how are we doing? Quite low. There's no issue. The fan's cranked to a crazy high 6700, so it's making more noise than usual. But everything looks fine from a motherboard temperature perspective. So that's all good. Now we just need to wait until we have a couple of settled down Windows 10s. Okay, Optane doing quite nicely on the right. So the very first time I've ever seen a VM running on Optane. Again, albeit very tiny, not a lot of storage. Let's have a look there. Look at our Optane data store and go to summary view. I've used up half of it. Okay, with this one VM. Nope, 2/3. When you boot it, the amount of swap is equal to the amount of memory. So how much memory does this VM have? It has 2 vCPUs and only 4 gig of RAM, but a 4 gig swap file goes down, taking up even more of that 32 gig Optane. So you're not going to be booting a VM with a lot of RAM on here. I have 128 gig of RAM in the system. Wouldn't even be able to boot that because it would use up all the available space in the Optane. You would need to put that on some other drive. I do not have a good theory of why my 960 is underperforming right now. Normally there would not be such an incredibly slow boot time over on the left. There you go. Since it's booting twice, that seems to indicate something else was going on. I don't know. The second boot's probably going to be just fine. So I'll probably never quite know what just happened on the left. All right. But I should see that my startup script that runs Task Manager to convince us that things have settled down over here, that should be coming up here on the left. It's on a delayed 30-second start, I believe. So startup scripts on the left should catch up. And once we see Task Manager on both have settled down, I should be ready to run my first ATTO dispatch on both. Okay, startup script is done. Now the machine should have a chance to settle down. Okay, 2 vCPUs for both. They've settled down. But clearly the disk on the right is doing some housekeeping of some sort. And this is just what Windows does. So you typically want some cool-off time to avoid that kind of nonsense from getting in the way of benchmarking of any kind. So this is a pretty informal benchmark, but these machines are pretty much settled down now. And now it's time to... I gotta find where I put ATTO on these. So I've closed Task Manager, and I have as few of things running as possible. If we look under here, there should be nothing to see there. Okay, VMware Tools, usual Defender, and USB ejection. Okay, so ready to roll here. Again, we've had a few mysteries pop up in this video, though. Let's just make sure that Task Manager still confirms. There's pretty much nothing going on here behind the scenes. I would say that's confirmed. And now we're ready to roll with my very first ATTO. Okay, there it goes. Bottom right, you have kind of a stopwatch. Looks like I started at 7 seconds after, but that doesn't matter how long this benchmark takes to run. What you're looking at is the actual raw numbers. Now, running both of these simultaneously is a bit bonkers. One is in a PCIe riser card. The other's on the motherboard. Doesn't matter in my experience, though. I've found a speed degradation depending upon if you're located on the motherboard, like the 960 is, or in a riser card, an AmFeltech card, on a bifurcated slot. I get full speeds. If you're running VMs on a PCIe times 4 M.2 slot device, like the AmFeltech riser card, well, then, of course, you're going to have, an awful lot of activity. But even then, since it's a by 16 slot, they should each keep up. And my experiences have shown that. So the fact that I'm running these two at once may or may not affect things all that much. They're still both hitting the PCIe bus, though. It's not ideal. I'm just doing that for my first run to get a sense of, do I see a difference from the get-go, Optane or not? And so far, not really. Actually, the Optane is being outperformed by the 960 on the left a little bit. Now, mind you, it is possible, once I Google around, like in the past, Intel wanted you to use their NVMe driver for their 750 series PCIe card, for instance. Right now, we just have the base ESXi 6.50D provided NVMe driver. And maybe that one is favoring the 960 on the left. And that does appear to be the case here. So the writes are slow on this little caching module for Optane. Now remember, this is a consumer module intended to be a caching layer for your operating system for astoundingly fast reads for under $100 to make a laptop feel awfully snappy, even if it has a spinning drive. That's its intent. So if I end up, even after I do a little homework and maybe throw a NVMe driver in there from Intel on the right, do I expect that to change things dramatically? I just don't know yet. Too early to say. Again, this is just my first look at Optane with the out-of-the-box driver from VMware. So I'm going to have a quick look here at that article. I'm going to bring up the 750 series driver speed article. Okay, here it is. So we have dramatically different results. And here we have an article saying we want Intel's VIB for full speed. Now these are older. There should be newer ones out by now. SSD family of NVMe drivers. So that's a Windows driver. So I'm being silly there. So what we need to find is the ESXi driver on that site. So this is Windows, okay. 5.5, let's see what version, 10E, 11, has that come along? All right, well anyhow, most likely this is what I'm going to want to use. But it's saying 5.5, which is kind of weird, right? But it might be true for 6. So I'm going to have to read the README and so forth in that bundle. Let me just go ahead and open that. Let's see if there is a README right inside of it. That would be convenient. And I'll next have a look at drivers. I have some other commitments today. I need to head out shortly, so I might not get this done now. I may need to just do a chapter 2 at a later time. All right, we've got an offline bundle with stuff in it, but I don't like those dates. So I'm definitely going to want to search a bit harder and find something that came out this year, right? But yeah, obviously Optane intended for consumer stuff. I really doubt there's going to be some Optane driver for Windows. What I really want to do is probably look for drivers that are intended for their oops, not on this page. Wow, I guess I blogged about that a while ago. I've been blogging about Optane for some months already. Probably want to look at drivers for their PCIe Optane device, the P4800X. Okay, this is like a product announcement. Maybe the Resource Center has a VIB download. That would have been too easy. Clearly not ESXi there. All right, I'm going to have to work on this. But anyhow, there's our initial results with Optane. How about I just run it a second time alone and then fast forward and show you the results. So first I'll do the 960 on the left, and I'll unpause video recording when that's done. And on the left, it just finished. Now start on the right. Okay, this round of testing is wrapping up. Very similar results, whether we ran both at once or not. All right, well, got to come back, look at drivers. Maybe I can get faster Optane performance with the consumer SSD. Maybe I won't. We'll see. Maybe I get different performance if I do NVMe pass-through to ESXi and then give that Optane module to a particular VM. It is the next day, June 11th. A little bit of Googling around. Didn't take long to find the latest driver for NVMe. And it looks like it's for their family of enterprise products, like the P4800X that I mentioned yesterday. Now, will it work on the Intel Optane meant for a caching layer on your laptop or something that I went and bought and put VMFS on? Well, we're about to find out together. Let's look at the README first to see if there's anything interesting in there. And I'm going to have to log in. Okay, so I paused, logged in, I'm back, unpaused, looking at the README. Should be possible now if we just click on Read More, we can see the PDF that we're about to get. And now let's have a look at the PDF together. Whoops, looks like I clicked it twice. There we go. April 2017. So it's pretty recent. And added support for Intel Optane devices. So this unified NVMe driver for Intel products with support for Optane devices added. Notice here it doesn't say what devices. I don't know. No better way than to just go ahead and try it. So here we go. Okay, so it's going to be a bundle. 6.5 it actually says, which is promising. And now I'm going to go ahead and get that on my screen here for you to see. Oops, secondary monitor. There we go. Let's right-click that thing and extract it all. And I'll go ahead and put it in this folder. Okay, so what we have is the usual structure. Zip inside a zip. So we can do another Inception style unzip. And you got a bunch of stuff in there, including the actual VIB. Alright, so what's the difference between these two VIBs? The one that was at the root and this one. Probably nothing is different at all. But I don't like probably. I'm going to go ahead and compare the two. This is getting a little weird. Sorry about that. Right click while holding down Shift. And darn. That's right. You can no longer easily open a command prompt. Whatever. Let me just navigate my way there. CD / and then I used copy as path, so it should get me that directory. Alright, so what are we trying to do here with the file comparison? So they're the same exact file, they just have different names. Okay? So this file is kind of inappropriately placed. I just put it there temporarily. Alright, now what happens when we look inside the VIB? Like double clicking it doesn't know what to do with it, so it's going to ask us what do we want to do with it. I'll show you a notepad or probably better WordPad. And it's going to look like this. Driver and descriptor and then gobbledygook. Alright. Now to make it easy to install, we can put it in temp. So that's probably a good way. There might be a short pathway. You can pull it straight from a web server and get a driver. And I've done that before for 10 gig drivers, for instance. Let me think about this. Yeah, probably best for people to get used to using something called WinSCP. To log into the host in question, go to temp, and then over here, alright, so we have the driver VIB. We put it in temp by dragging and dropping it. It's nearly instant. Now we need to putty our way to it. Pull it down and type some stuff. And then patch it. So that's what we're about to do. So I've got that on my clipboard. And now I'm ready to run putty. And to log into this ESXi host. So now if I right click and paste that, complete or type ahead, autocomplete should work just fine. And that's it. So I move the file into temp from the web, type this command, and I should have myself a faster Intel Optane performance. Maybe. Will it degrade the Samsung NVMe drive that's also installed in the same system? Don't know, but about to find out. And a before and after test of that should be simple enough. Yeah, notice in the screenshot in the bottom, after this installs, it's going to say something about is a reboot needed? And absolutely. And then finally, do I have any VMs running or anything that matters? There you go, reboot needed, yes. Vib installed, the one we wanted. Excellent. So I have it set to gracefully restart vCSA appliance, and that's the only other VM on there right now. So for me, I can go ahead and reboot, but you may darn well want to go into your UIs, gracefully shut down any workloads you have. I wouldn't want you to lose something based on what we're doing here. Okay, so the ESXi host is now going to be rebooting. Well, of course, we're going to have an interruption in service when doing that, and I'm going to lose all my vSphere web logins. But because we have a backdoor IPMI way to look at the VGA output of the server, virtually, you get to see the whole experience of watching the server reboot without any interruption. So there'll be no appearance of smoke and mirrors here. You're about to see the ESXi host itself begin to reboot. Now, while we're waiting for that yellow screen over on the right to light up, there it is. I was going to show you over on the left, maybe, that the vSphere UIs are starting to die, but that's about to happen anyway. Putty's going to die. There you go. Putty is probably, or WinSCP is already unhappy. Makes sense. How about Putty? Did that croak yet? Yep. Okay, so it's going to take a little while here to get everything back. These UIs are all going to be toasts, and I'm going to need to re-authenticate all of them, including remote console sessions, of course. All right, it's going to take me a little while to get back to where we were. So I'm probably going to pause the video at this point because there's not too much going on other than watching ESXi itself reboot. Okay, I'll leave it recording a little longer. The NVMe driver is loading at some point in here. Okay, I finished the reboot. And just having a quick look here under storage adapters or storage devices. Did anything significant change here about the way things are seen? Probably not. All we did was change the driver, so that wouldn't show here anyway. How about vSphere web client? Here's how the Intel Optane looks over there. Again, now formatted. PCI devices list. Nothing's passed through. All right, I think it's time to move along. So the VMs, we can do this from here. I renamed 960 to 960 Evo because there's a 960 Pro as well, but this machine has a 960 Evo in it. So the intent there was to try to make it clear when I do screenshots from here forward as far as who's obtaining which speed. All right, so now I'm just basically trying to set up to get back to where we were with the two windows side by side and the two VMs essentially at idle. Now I should be able to test ATDO dispatch, and it should be very clear if we have a speed up, since it was very clear when there was a slowdown. So here we go. This is kind of the drum roll moment. Intel's preferred NVMe driver loaded. We're about to find out together. Do I get good performance in my Intel Optane in this VM shown on the right now? So this is exciting because it's first for me, and already the numbers match. The next row is where it gets more interesting. Do they start to exceed the 960 EVO on the left? I do also have a 960 Pro on another host, but they perform very similarly. What I'm hoping to see is significantly higher numbers on the Optane, but that's just hope. I have no evidence that that's going to be the case. Okay, we are underwhelming in our performance so far. Maybe the next row will be more telling. I could also boot over to Windows and NTFS format this and see if the Optane does better as a straight up ATDO dispatch under Windows 10 without VMFS, but frankly I was much more interested in this Optane's performance as a VMFS data store. The writes did not budge, so the driver didn't touch anything, is my initial impression here. So this would mean that buying a 32 gig VMFS data store drive, a tiny Optane for under 100, probably doesn't make a lot of sense for most people. Now, does it make a good vSAN caching tier? That's TBD. But as far as in this, and it's not supported by the way, these little M.2 chips, the supported vSAN Optane drive is the P4800X, the PCIe card. So a whole different animal. So it's topping out. Driver made no difference. Learned a lot, but also kind of sad. I really was hoping I had stumbled upon a cheap way to have ridiculous performance just to get a taste of Optane without the full-length PCIe card. And so far the answer appears to be no, but I don't know. Maybe I'll stumble upon another NVMe driver VIB at some point that makes this turn around completely. So probably the next course of action would be the pain of, well, booting Windows somewhere. I only have two machines. They're both running ESXi, so it's a bit painful to dig up an SSD, put Windows 10 on there, reformat this Optane as NTFS, and run ATTO all over again. So having a look at the video in post-production and seeing that when it booted, both NVMe drivers were loaded, that had me realizing that it's simply time to roll up our sleeves and work a little harder to get only one NVMe driver loaded. So this reminded me of Anthony Spiteri from Veeam, his article about Supermicro and HCI, sometimes ending up with an old and a new driver, and things not going so well, and he talks through how to disable. Okay? So we're going to use the same technique here. So let me show you. We have, let's see, both windows sized, and here's the command right there. So I'm going to grep. I'm going to look for NVMe drivers that are loaded. And we can see there's two of them plus a plugin. We want to get rid of the one that's just called NVMe. So I'm going to go ahead and do that with this command, adapting it for our needs. Now I don't want to hit enter. Let's see if that worked. Yep, that worked. So before I hit enter, let's just confirm. So the VMware native driver in this example was disabled with that simple command. In this example above, I'm going to disable VMware's native driver with this simple command. That's it. All right. And now let's see if we can replicate the rest of the behavior shown here. Actually, how about I just, if we do the grep, that's not going to change any, right? Because we didn't unload it from memory. But if we take this command and put it in, we should see everything. Okay, let's try that again. That's pretty ugly. Okay, there's all our modules. And if we look at NVMe on the next page, and hit spacebar now, or maybe the next page, there's obviously a lot of modules to look through. All right, I missed that. Let me just take a look here. Let's try that again. Looking very carefully for NVMe and seeing is loaded and is enabled. We expect NVMe to be loaded, true, but is enabled, false. So after the reboot, we should be fine. So that's it. We should be good at this point. Now I just need to resume this video when the system is back up. Well, I rebooted, logged into ESXi host client, and doesn't look so good. A whole bunch of VMs missing. So that's a little weird. How about the VCS or web client? Let's go with that. What do we got? So on the summary tab, we have a warning about syslog. Okay, so that implies data store disappeared. Well, kind of already established that. So if we look at storage adapters and storage devices, let's see under storage devices, we have the Intel. What we don't have is the 950. Oh boy. That's tricky. So the 950 just disappears. Okay. Well, on the bright side, we can test out this VM. Let's do it from the HTML5 client like I've been doing. So we have ourselves an Optane VM, but we have an inaccessible 960 Evo VM. Interesting. So having a multi-vendor NVMe set of storage is proving thorny. Something I asked about at a user group like 18 months ago as VMware was presenting their NVMe future products. And doesn't look like that's gotten better. This boot speed looks pretty good so far. So setting aside my sadness for lack of multi-vendor support at the moment, let's just see how NVMe performs in this one VM that has the Samsung driver loaded. That precludes visibility for all non-Samsung drives, or at least, sorry, all non-Intel drives like Samsung are not visible with the Intel NVMe driver loaded. That much we can tell here. All right. So the machine's had not a whole lot of time to boot. The 30-second delayed startup script, though, did finish. And all it did was launch Task Manager here. And indeed, the disk is now settled down, and so is the CPU. And I want to do, more than one run like you should with any benchmark. This has not had any cache or warming of cache or any of that stuff. This is just a fresh boot of a VM that's clearly on an Optane data store. Let me show you that. If we look here at the hard disk, Optane. It's on that data store you saw me create earlier in this video. All right, here we go. So busy talking. Just want to make sure Task Manager didn't light up with some strange background process. Nope. Still very much at idle. Here we go. So, kind of my second drumroll moment. This time I'm actually convinced I know that the correct VIB is loaded. Cool. But I have no idea how the performance is going to go. So these moments of discovery are always fun. So far it looks terrible. Not sure what's going on, but I'm not even getting my first line, which should have been drawn by now, first result. So it would appear that this isn't going well. That's my initial impression here. Darn. Those numbers are terrible. Sneaking a peek here at the old graphics, 27,000 for the first. Okay, we're creeping up in the second result. It's redeeming itself. So, it's still not amazing. Don't know what to make of that other than NVMe storage in general. Like 1 in every 10 benchmark runs on average, something like that. Over the last year or so, I'll get a mysterious slowdown. I can't explain that. That could be housekeeping, garbage collection, something going on in the background, but shouldn't happen that often. And then with Optane, you would expect that even less. It's supposed to be a consistent performer no matter what. So, not sure what to say there. Okay. Now, there's no impact of moving this over. There's no slowdown. This is not remote desktop. Let me just see, how does it compare to the previous results? So, we have 960 Evo on the left. We have Optane on the right. And we want to see if we can break past like 2000 for the reads at least. And it looks like we might be hitting that same 1400 megabytes per second cap we were seeing in the previous run. So yeah, doesn't really look like we got any progress here. So comparing old Optane run to new Optane run. What's the verdict? Essentially identical numbers, except for that first miserable outlier. Everything else about the same. So this whole testing thing has been a bit full of surprises. Running it a second time, I suspect the first outlier will go away, but at this point, who knows? Maybe I'll be wrong again. But that is what I'm going to do. No evidence of thermal throttling. The green doesn't dip after we're keeping the thing busy for a while, so just run it again right away. That first number is of most interest to me. There you go. As expected, the outlier vanished. So some inexplicable reason, maybe Windows was busy doing something. That is an example of a mystery. Nobody likes a mystery when you're trying to understand how something works, but well, I'm stuck with them anyway, whether I like them or not. All right, here we go. Are we doing any better? Probably not. Nope. Slightly, maybe, but not significant. So this is going to kind of draw a close to my Optane with NVMe driver testing. I'll need to see if there's an NVMe driver specifically for the consumer device. I'll also want to run Magician against it. I have no idea if Magician supports Optane, but I need to fire up Windows, format it NTFS, or not. Just run Magician on that Windows instance. See if Magician says, oh, I've got a firmware update for this Optane device, 32 gig size that you have. That might make things interesting. That could be revealing. Or it might be a giant waste of time and do nothing. And it'll probably take me about an hour. Don't really know until I try. All right, I can already see enough here that this isn't likely to be a fruitful second test. Other than the first outlier just vanished, everything else essentially identical. So you're now seeing the consistency of repeated runs of NVMe tests that I've been witnessing for a year and a half. Doesn't really seem to matter if I run it once or 3 times. Get a pretty good sense unless there's a ridiculous outlier where you get like 1/10 the speed you expect. In which case you tend to disregard that result and run it again. Important in production, not so important in a home lab. That happens only 1 in 10 times on average. I am extra surprised to see it on Optane though, where you shouldn't have any background housekeeping or NVMe related kind of RAID adapter, basically a NAND RAID controller, I should say, being busy with something. Now it's unlikely that. It's more likely just maybe Windows housekeeping or something got in my way. So the lesson to learn there might be, I might need to pay more attention to benchmarked optimized settings for these VMs here. I'll also point out this is the para-virtual SCSI adapter. I might also want to try this with the LSI adapter, see if something surprising happens, but from my previous tests, didn't matter. Essentially the same results for either SCSI adapter used inside the VM. That's going to be a wrap. Hopefully you found this video helpful. Thanks for watching. And thanks for visiting tinkertry.com.